Hello there, my name is Brian Murphy. I am a staff analyst with the New York City Government, and I am also pursuing my master's in cybersecurity at NYU. This is my presentation on NYC Open Data and using Python to explore NYC Government datasets and things of that nature. So first, as an overview, I'm going to be looking at the New York City Government and some challenges and datasets related to it. We're going to be looking at Open Data, which is a portal for free, open, and public data sets that anybody can take advantage of. I'm going to be going over a few data sets and why they might be interesting. And then I'm going to be showing off some Python code that you can use to actually query these data sets. First of all, who am I? My name is Brian Murphy. I'm a staff analyst in the New York City Government. I have about 5 years of service within the government, and I started out as one title before transferring over to another one. I also serve as the Information Technology Officer for ACES, which is a fraternal organization at my particular agency. And I consider myself a backend developer as well as technology enthusiast. So you can see some of my certifications below. I have certifications in Microsoft Azure, Database Fundamentals, and Rasa, which is a machine learning AI-based chatbot system. I'm also pursuing my master's in cybersecurity at NYU as a cyber fellow. And there's my LinkedIn. If anybody watching this would like to connect to me, you can feel free to reach out to me and let me know, just if you have any questions, comments, concerns. And my email is also in the bottom right-hand corner of each of these slides. So feel free to shoot me an email there. So first of all, we're going to look at what is the New York City Government. It's one of the largest municipal workforces within the United States, and that comes with a lot of titles, which are covered by many unions. We have everything from custodians, police officers, analysts such as myself, and a whole lot more. Now, the government employs about, let's say, over 100,000, hundreds of thousands of employees, which cover all of those. So this workforce obviously brings up a few questions, and 3 of them are here. One of them is, how many unions are there? How many titles are there? And then how many unions are covering each of those titles? Like how many titles are in each union? So that means you could have, let's say, 100 unions, but if each of them covers 2 or 3 titles, or there are only a handful of unions that cover, let's say, a couple hundred each. So we're going to be answering those questions in a bit. And how? Well, there is Open Data, which is a free portal to New York City government data. And this was made about 10 years ago as a way to increase transparency within the government and provide some sort of, let the public know what's going on and how things work, kind of. Now, this data set is available, it has a lot of data sets, which are available in many ways. It has a website visualization tools, and you can download it as a CSV or a JSON file, and you can also access it via the Socrata API, which uses a SQL-like structure to actually get data and allow you to filter, do where clauses, things like that, as well as offsets, which we're actually going to be using in a minute. So this is updated rather frequently. Some data sets are updated almost daily. Others are updated every few months or year. But this varies by data set, and there are always some data sets that are going to be way more updated than others. And there's a link to this, and I'm also going to be posting a link to these slides in the description, so you can feel free to take a look at these slides and then go to that link if you're interested to learn more. Before we look at the Python code, I'm going to be going over the results. I found that there were 44 total unions and about 2,105 titles with unique descriptions. So what do I mean by that? So in the right-hand image, you can kind of see what I mean. So executive program specialists show up 22 times, investigators show up 21 times, strategic initiative specialists show up 20 times. So I found over 3,023 titles total within the data set we'll be using. And there were a lot of title descriptions that were used over and over again. So that's why you would see some appearing over 20 times. And then after this is the Python code, which we're going to jump over to now. So this is the Python code, and I wrote this all in Google Colab, so I'm going to close this table of contents here. so we can take a closer look at this. And let me go ahead and click and zoom in a little bit. All right, so like I said, this is an EDA of New York City government employees, titles, unions, and more. So this is more or less the description that I already just gave you. And we can, if you click here, when you go into the Colab, then you can actually take a look at the actual data set, which is actually, I have it open over here. So here you can see that we have New York City government titles. This was last updated November 3rd, and it has 3,023 rows. So, and each one of them is an actual title. And then over here, it shows you all of the columns. I'm going to be showing you another way to look at that in just a sec in actually Python. So over here, we have the questions once again. First one, how many titles, how many unions, and how many titles are in each union. Once again, I have an introduction in this Colab notebook to information about the API portal. And now we're going to actually, so in this Datascience Bootcamp, a lot of stuff we've been looking at pandas and Seaborn, which is rather new to me. So I decided to take advantage of those skills that I've learned and use those to take a look at the data. And also we'll be using the request library, which is another library you may need to install. So going to the Python code, you can see here that just in case anybody downloaded it on their own or wanted to run this locally, they would have to install Seaborn as well as requests. So I think Seaborn, when you install that, that's going to install pandas and a bunch of other libraries that you'll need. So that takes care of all of that. And requests is actually a way to get information via HTTP, like using URLs and stuff. And over here we have the libraries we're going to be using. So we have requests, Seaborn, JSON, pandas, and PyPlot, which is used to actually plot our data and stuff. So over here we're going to be looking at how to get our actual data. And the first thing here, I've defined the URL. So this is the URL to the actual data set. And like I said earlier, this uses the actual, it uses Socrata language, which is very similar to SQL. So you'll see here, I have another string that says offset. So that's some of the filters that you can do using this API. So, and .json, that obviously is going to actually open it up in a JSON file, in a JSON format. Which if we follow this link here, this is overall what the data looks like. As you can see, this is in pretty standard JSON format. So this is how our data is actually pulled in using this API. Now, another thing to note here is if we change this from a JSON to a .csv, that would allow us to actually download the data as a direct CSV file. Now, the first thing we're going to do is we're going to use pandas to read it in this URL. And then we have this for loop. Now, something interesting about the Socrata API and something you may want to keep in mind if you work with this is that it only pulls in the first 1,000 records or 1,000 if your offset is 1, it'll pull everything from 1 to 1,001. That's kind of how it works. So if you want to get all of the records within a data set, then you're going to have to use some sort of for loop to keep on requerying the data set. And that's what that offset is doing here. So here we have our data, and we're going to append our URL plus our offset, which is up here. That's our filter, plus STII, string I. So that's going to pull in. So originally we have everything from 0 to 1,000. Here we're going to be pulling everything from 1,000 to 2,000. And then when it hits a 2, we're going to pull everything from 2,000 to 3,000 and so on. Now, obviously, I could have stopped this at 4 because that would allow us to pull everything, basically. But just in case, I went with 5 just to make sure, absolutely certain I got everything. So, after we pull in all our data, what I did was I printed out the keys, which we'll be working with, which are those columns that we saw a second ago on the actual data portal site. And then I printed out the length of the data just to make sure I got everything. So here, 3,023. So, got everything. And then I printed out the first item and the last item. So here, we have our title, description, standard hours, how many hours they work, the assignment level, union code, union description, bargaining unit, bargaining description. So those things are related to union information and things like that. min rate and max rate. So that's like the minimum pay and the maximum pay that that particular title can make. And over here, of course, we have, this is the first item, this is the last item. Before we get into anything, let's look at some overall totals. So these answer two of our questions right off the bat. And the first one is we have 44 unions, which will represent 3,023 titles. And then we have 2,105 titles with the same description out of those titles. So like we saw in the other picture, there were some titles that appeared multiple times. So I used the value count function to actually get that information. Now next, I was a little bit curious about how the actual titles, broke out and why that was, we got 2,000 of them. So I took the top 5 title descriptions and I made them into these, used Seaborns to actually plot them out. So here by default, Seaborns has things pretty small. So I played around with the figure dimensions until I found a value I was happy with. So, I went with a 10 by 5. And then I actually, made that into a plot. And then I decided to print out the top 5 values for those value counts, which are down here. So executive program specialist, investigator, and so on. And then I used a count plot to actually plot the rest of the data. So I actually, my Y value, which is over here, is my actual description. I had the data, the count, ordering it by the most populous, so the highest count goes on top for the first, and then I also only pulled the first 5 of those. And then I was also playing around with the hue just to see if I could color them differently to figure out, what unions cover which titles, but it kept giving me more titles than I needed, and it was just needless, so I decided not to do that, but that was something I was playing with. And then, of course, I show the actual plot, so, this is what it looks like, so it goes from here all the way down. So it's interesting to note here is we go from 20, 20, 20, then we go 14 and 12. So it's a pretty steep drop-off from like the top all the way, even within the top 5. But this isn't as dramatic, actually, as the unions. So I did a lot of the same stuff here. So, I kept the figure pretty much the same. And then I printed out the top 5. So what's interesting here is we look at the non-union. It turns out that of the 3,023 titles, 1,502, almost half of them are non-unionized titles, or at least were classified as non-unionized. Now, below that is a huge drop-off from 839 to DC 37, District Council 37, which is the largest union within the city. And that's true because, look, International Brotherhood of Teamsters only represents 137, and they're in 3rd place. Followed closely by CWA, which is 85, and Service Employees International Union, which covers 83. So even within this, going from here to here, there's a huge drop-off, and then there's a pretty big drop-off from International Brotherhood to CWA. So you can kind of see how that actually plays out. And it's rather interesting to note. Now, just to round this off, what I did was I decided to actually print out the value counts, and there's 2,105 rows of information here, so you can see that the overwhelming majority of them seem to show up once or twice. So yeah, you go from 20s all the way to 12 within the top 5, and then it goes down from there. And that's, this dot dot shows you that there is actually going to be, there's more in between there. Now, because the bargaining description, which is the unions, were a little bit smaller, we were able to get everything printed in here, all 44 of them. But you can notice that it seems as though there's a huge drop-off, even within the top 10. So we go from 1,502 to 839, 137, then we go to 85, 83, we go to 60, 45, 39, 30, 30, 21, 10, and we basically go from the top 10, and then all of a sudden everything is just suddenly single digits. And then it goes down from there, and there's a handful that only represent 2 or 3 titles. So Some of these kind of make sense because you have unions like the Lieutenants Benevolent Association, which really only represents, which is, as I understand, a police union. So they only represent like the lieutenants and their specialized titles. So that kind of makes sense, and if you take it in that sense. But then you have others like Organization of Staff Analysts, which represents 45 titles. So yeah, that's pretty much it for this portion of the presentation. Now, I'm going to discuss some of the pitfalls and shortcomings of this data set. So one of the problems with this set is that it doesn't necessarily tell you when a title is retired or when a title was changed or things like that. So, for example, like you may have a title that had a certain description 10 or 20 years ago that was used for one thing, and then it changed over to something else. Like let's say it was covered by one union, and then it was covered by a different union later on. So they may show up twice in that data set with that same description, and the only real difference would be those union things. It also doesn't say when, like I said, like titles retired. Sometimes titles are retired, meaning they aren't allowed to be used anymore. So they may still show up here, and there's nothing like that. And they also don't have like when the titles were actually made or anything like that. So a lot of these titles may not actually be being used, which may be why we see a lot of non-unionized titles within this data set. So those are some of the limitations there. And also it doesn't have exactly how many, this particular data set doesn't have exactly how many are employed in each title. To get that information, we would probably have to combine this one with another data set, or at least try to, available on the Open Portal data set, Open Data Portal. All right. So, just to close it off, once again, my name is Brian Murphy, a staff analyst with the New York City Government. There's my LinkedIn, there is my GitHub, and a current YouTube link, which is going to be outdated as soon as I post this. And I'm actually going to go ahead and remove that current YouTube link. So that was the previous video. So when I actually post this video, it will be out of date. So I am going to update the slides with whatever the new link ends up being. Okay, so thank you all for watching. If there are any questions, comments, or concerns, you can feel free to email me or comment on this video. And of course, you can always reach out to me on LinkedIn or my NYU email. So, I enjoyed doing this. I wanted to give a big thank you to Sagar Patel for running the Datascience Bootcamp for fall of 2020 run. Did a great job. I learned a lot, and it helped me make this video and presentation. I hope you all learned something, and have a great day.